Let's practice solving a quadratic trigonometric equation that has some trig identities as well. Keep in mind that there could be an infinite number of solutions for these types of equations, but we're just going to be looking for the ones between 0 and 360 degrees. And if we have to do any rounding, let's go ahead and make sure we round to the nearest tenths place so we are on the same page. I'm going to go ahead and start by just copying down the equation here. So we have 2 times this cosine of 2 theta. So we have a double angle going on over here, minus 10 times this cosine of theta, plus 8. And that's going to be equal to this negative 6 times cosine of theta on the other side, plus 5. So at first glance, we should be pretty happy that we at least have the same trig function of cosine throughout the entire equation. But you want to be careful and notice that we have this cosine of 2 theta, so we have a double angle formula. Now don't worry if you don't remember your double angle formula, you can just go ahead and look that up. And you can find that this cosine of 2 theta is equivalent to 2 times cosine squared of theta minus 1. While there are other identities that we could use, this is the best one because it's going to keep our cosines all the same throughout the equation. So since these are the same, let's go ahead and substitute this 2 times cosine squared of theta minus 1 in for that cosine of 2 theta. In doing so, we're going to get 2 multiplied by this 2 times cosine squared of theta minus 1. And then we're going to have minus 10 times cosine of theta, so we're not really doing anything with this yet, plus 8 is equal to negative 6 times cosine of theta plus 5. Then distributing this 2 so we can kind of simplify this equation just a little bit here. We're going to get 4 times cosine squared of theta minus 2, and that's going to be minus 10 times this cosine of theta plus 8 is equal to this negative 6 times cosine of theta plus 5. Now you can go ahead and rearrange the equation now so that it's written in standard form. And we can go ahead and use u substitution right now so that we don't have to keep writing cosine of theta over and over again. So if we let u equal cosine of theta, we can go ahead and swap u out for that cosine of theta. Alright, so this should be a little less writing for us going forward. So this is going to be 4 times this u squared, just because we have cosine squared of theta. Then we have minus 2 minus 10 times cosine of theta, so that's going to be u again. Then we have a plus 8, and that's going to be equal to negative 6 times u plus 5. Now on the left side, I'm just going to go ahead and combine like terms, this negative 2 plus 8. So if we do that, we're going to get 4 times u squared minus 10 times u. That negative 2 plus 8 is going to be 6. And that's going to be equal to negative 6 times u plus 5. Now let's just go ahead and turn this quadratic equation into standard form. We can do that by just moving everything to the left side so that we can try to factor, and if not, we'll use the quadratic formula. So let's go ahead and add 6u to both sides of the equation, and then we can also go ahead and subtract 5 from both sides as well. Now once we use those properties of equality, we're going to have 4u squared. And then negative 10u plus 6u is going to be negative 4u. And then that 6 minus 5 is going to be a positive 1. And this is going to equal 0 on the right side. Now at this point, it's a good idea to try and factor this trinomial. But unfortunately, this particular trinomial is not factorable. So we're going to go ahead and resort to the quadratic formula. Okay, so we need to know our a, b, and c. In this case, a is going to be 4, that leading coefficient. B is going to be negative 4, the coefficient for u, and then c is going to be equal to positive 1, that constant term at the end. Alright, so what is that quadratic formula again? Alright, so there it is right here. Now I'm using this variable of x because that's usually what people use with the quadratic formula, but hopefully you know that this is really just that u that we had earlier. Hopefully this part is a little bit of review, so I'm just going to speed through this process. So going through that entire process here, we're going to find out that x can be 2 things here, but really just 1. So 4/8 simplifies down to just being 1/2. This right here just means that we have a perfect square trinomial. We can go ahead and substitute this back in. Remember, u and x essentially were interchangeable here. So plugging this back into our equation here, we can just say that u is equal to this 1/2. Okay, we don't have to worry about the other solution just because it's going to be the same thing. And let's go ahead and substitute back in. Now remember what this u was really representing. We said u was representing this cosine of theta. So substituting that back in, we're going to go ahead and say that cosine of theta is equal to 1/2. Now to find this angle measure of theta, let's go ahead and use our arc cosine function. So theta would be equal to arc cosine of this 1/2. And if we plug that into a calculator, or we can just use our unit circle, because this one is going to be one of the nice ones from our 30, 60, 90 triangle, this is going to come out to being 60 degrees. Because we're looking for angle measures between 0 degrees and 360 degrees, we're going to say we like this answer. Now, while this is one answer, I do think there's one more out there, so let's go ahead and see where that other one is, and hopefully it makes sense. Alrighty, so on that unit circle, we can see here that 60 degrees would be maybe roughly here, give or take, right? And I'm just gonna go ahead and draw a triangle down. So 60 degrees is gonna be that reference angle right over here. And our ratio was gonna be 1 to 2. Now cosine, remember, is x over r, also known as the adjacent over the hypotenuse. So we have a 1 to 2 ratio. So 1 would be the adjacent side with the x value, and then our r value or the hypotenuse would be 2. So again, not quite the unit circle, but has the same ratio. So hopefully you get the point there. And if we go ahead and see, okay, well, this is 60 degrees and we get that positive ratio of 1/2, but is there another location where we could draw this triangle so we get the same positive ratio of 1/2? Now, hopefully you can see here that we were able to draw this 60-degree triangle over in quadrant 1, where cosine is a positive 1/2 ratio. I gotta ask ourselves, where is there another location, if there is one, where we also get positive 1/2 in another quadrant? So again, we had all of them, just sine is positive, just tangent, and just cosine. So cosine is also gonna have a positive ratio in quadrant 4. So let's go ahead and draw another 60-degree angle, but this time over in quadrant 4. And we have the same reference triangle here. 1 is still going to be that adjacent side, that's right over here. And the hypotenuse or the radius side is going to be 2 over here. So we have our 60-degree reference angle here. So to get this ratio of positive 1/2, we had this 60-degree angle here, but we also just found out that we could draw another triangle over in quadrant 4 that also gets us the same ratio as positive 1 to 2. Okay, so if we go ahead and write that down, this location all the way in quadrant 4 is 60 degrees away from a full circle. So we can go ahead and say that theta would be equal to 360 minus 60, also known as 300 degrees. This happens to also be between 0 and 360, so we like this answer. And so we can go ahead and summarize. I think that's going to be all the answers that we can get between 0 and 360. So our two solutions here are going to be 60 degrees as well as 300 degrees. Alrighty, so that just about wraps up this video on solving this trig equation where we had to use our double angle identity. If you found the video helpful, please consider giving it a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing, and I'll see you in the next one.